Hey Nilo,
Hey, how are you doing?
I'm doing good. I'm just having a bit of cold, so my voice must not sound very clear, but yeah, I'm really looking forward to the space. Oh, Marino is also here.
Nice. How was your KubeCon? Not KubeCon, sorry, Cube Day, but it looked like on Twitter that it was a KubeCon, to be
Yeah,
honest.
yeah, it certainly like looked like a mini CubeCon. So yeah, it was like first time happening in India, and it was really great. I met a lot of folks, and it was a really well focused event. So yeah, it was really nice.
Cool. Sounds super interesting.
Hey Kat, hey Marino.
Hey, Concha. Last one of the year.
Yes. Like totally new topic and I'm really looking forward to this.
Hey, how's everyone doing?
Neela, you are unmuted. Are you like I'm not able to hear you?
I am muted. No, I'm unmuted, right? So you hear me, right?
No, now I can. Like I thought you was going to speak something.
No, I think that might have been just some noise from the office background.
Okay, all right. So I'm just waiting for a minute and then we can start. Or should I start? I'm okay with anything.
It's always good if no one says something, right? So,
Okay, we can start then, and then people can join in between. Yeah, so hey everyone, thanks for joining in today's Twitter space, which is also our last space for 2023, and then we will see you in next year. So today we have our amazing speaker Neela with us, who will share about all things related to observability, be it dissecting the intricacies of effective log management, telemetry, and monitoring. We will also explore how granular observability not only identifies bottlenecks but transforms raw data into actionable insights that can fuel the peak performance. So, welcome, Nilo. It's great to have you. Also, a quick shout out to my amazing co hosts of the day, Marino and Kat. And we are all set for a great conversation. Also, if you have any questions, thoughts, feel free to drop them in the comments below and we will be happy to take them up later. So, yes, let's start it and learn together with Nilo. Would you like to give yourself a quick shout out and also could share what is observability in a broader prospect for folks who aren't familiar with the term?
sure. First of all, thank you for inviting me. I'm also super happy to be part of the last one of 2023. So, really cool to be here with you in this space. Yeah, so well, you said that my name is Nele. I work for a company and we built a tool around observability, and I joined a year ago. So, I would consider myself also not being the main expert. There are there are people that have been longer in the space, but I'm really curious, and I'm curious to share the things that I've learned basically during this year, and also see what other folks think in terms of observability. And before we start, I think it's a really good idea to define what we understand under that term, because it's very broad, and I think it's used also quite frequently with a lot of different sayings. So when I refer to observability, I think of understanding our systems based on output data, and that output data we call telemetry data. And basically, that consists out of three types. So we have logs, traces, and metrics. And you could consider that all of them kind of contain the same information or similar information, but in a combination, they get quite powerful. So I can give you a quick example. If you look at a log, you find, for example, in a log the duration of a certain call. So you get the nanosecond something has taken for a specific call in your system. But that information alone is really useless because you have not the context of the overall system. And that's actually where metrics come in and be really handy, because metrics are over the time the accumulation of those values. And you can understand based on the metrics now if that specific call in the logs or the duration that you have from the logs is actually a value that is related to the other values you have, slow or fast. And based on that, again, you have more insights of the specific behavior. And then the other part that also is important actually are traces, because if we have distributed architectures and services, it is often not enough to only look at a single call, but it's a causality that happens in our system. So it can be basically a whole call chain. And with a trace, we can track down the causality and can also understand basically if a certain call took longer, what was the causal effect on that. So maybe we can see there also some correlation. I think that's basically the three types that are important in, or the three types of data that are important in the whole discussion around observability.
Yeah, so you mentioned some different kinds of observability data, including logs, traces, metrics, and more. Is a particular type of data useful to debug a specific performance issue? And you also mentioned that using a combination of these metrics would be great to find bottlenecks and improve performance. So how can we combine these different types of data to get insights into the larger problem?
Yeah, great question. I think there are multiple ways of combining them, and the combination always happens in the tool in the end that you use for visualization. I think where we start when we talk about this data type is we need to get them out of our application, and I think probably all people here have heard about open telemetry and the way how it is unifying the way of instrumenting your application code. So it provides SDKs and tools and APIs to, basically have a vendor neutral way for the instrumentation. Then you store this data in whatever backends you want to choose. I mean, that could be some proprietary tool, but it could be also some open source tools in the space. For example, if you go for open source stack, let's focus on that. You might go for Prometheus for your metrics, and you might go for let's say Jaeger for your traces, or you use Tempo if you stay in the Grafana world, and then you also maybe use Loki for the logs, and then on top of that you build a visualization platform, and maybe that are your Grafana dashboards then, and that would be the place where you have also the possibility to combine the data types basically, and drill down.
Thanks for answering that, Nele. I will now pass on to Kat. Do you have any questions or thoughts to what Nele mentioned?
You know the breakdown, the different components in the logs and tracing and all that is pretty interesting. I'm hoping we dive into that just a little bit more to kind of understand how all of the different components fit together. If we want to go there.
So you mean like especially how we can, for example, like debugging then, especially based on those three types of data, or getting them out of the application first? I feel there's like more parts to it.
Yeah, so one thing that I think I'm interested in is really with logging, it's easy to wrap your head around if you think about it in one single instance of a tiny microservice or something like that, right? But to imagine it at the scale of like hundreds or even thousands of pods in a large deployment is really mind-boggling, right? So how do the components of logs and tracing and all of that make the overwhelming flow of logging data manageable?
Oh,
Like,
yeah.
is there any sanity in that practice, and what does that look like to you?
I think in an idle world, or that what I understand in the idle world in our observability flow, it would be you have set up first of all metrics, because metrics are great also to define alerts, right? So you can say, okay, I have a certain operation or a certain call that should take only that amount of seconds. And whenever my bucket is over that budget, I want to get an alert. And that's the first thing where you then get an observability actually indication that something is not performing in your system. And based on that, then you would like to drill down. Where does it come from? And then a really good combination could be to go and track down from the metrics that are linked to your traces to see certain calls. And based on that certain calls, you might see the specific call element that takes longer and then go down to that specific log. That would be the ideal scenario, that you have this correlation between the data so that you actually can drill down. And I mean, you mentioned it already. I think with logs, the thing that gets hard with logs is actually the storing, because if you imagine those thousands of pods, microservices, whatever you have running, and if you store all the logs, it can get quite expensive. So there are, well, I mean, there is potential to store all the logs. You need them for drilling down, but I think a lot of organizations I've talked to, they don't store all the logs because it gets too expensive at one point to store all of them. So I think a good indication to start with first, if something is off, is not the log, but you start with a metric and a defined goal of your system behavior. Did I answer your question?
Yeah, I'm sitting here trying to process through. You uncovered a lot of kind of nuggets or little pieces of the puzzle there. So storing is obviously a major challenge with that much data flowing through. How do you find the signals that matter, right? So if you're looking at any kinds of data, if it's not organized or understood or structured, you get a lot of more or less static, not unlike static on old, airwave televisions that weren't tuned right? Where there's lots and lots of data, but none of it is actionable until it becomes organized and understandable, right? So I'm curious, in your practice, how do you actually turn the massive waves of data into something that is consumable on a human level so that we can detect the important signals in the data and find whether it's an outlier or a trend? How do you actually find the important signals there, and what do you do with that information once you actually hone in on it?
Okay, I think there are two parts of like answering that on an organizational level, thinking of what is important and where you want to get alerts on based on SLOs, the service level objectives. So you define those based on the user experience that you expect your system to achieve, basically. So imagine you run an online shop and you look at the user and you can probably calculate what value you are losing if, for example, your payment service is down, or if if something is not working properly or takes longer, whatever. You try to understand it from the perspective of the user, and based on the perspective of the user, you see all the components that are aligned to that in terms of a technical flow. So it starts maybe with a payment service, but that is related on the infrastructure it runs, and then it goes down, and based on that understanding you can define that service level objective, where you say, okay, I do understand when we are like when this takes longer than 30 seconds, we lose, I don't know, I'm just making up stuff here because I'm not an online shopping expert, but I'm just making this assumption. If something takes longer than 30 seconds in a checkout, we lose, I don't know, 10% of our customers. And that's maybe the number that we don't want to lose. So whenever something takes that long, we trigger an alert, because that means we have an outlier behavior in the system. And that's when we want to start debugging. I think the question on the signal, I think that's on the, like, SLOs really help to think or wrap your head around like alerts in terms of the business value. So when do we need to get alerts to debug the system, based also on the business use cases. And you really mentioned correctly, there are a lot of signals, and can we measure all of them? Yes, probably we could, but what makes most sense, and I feel a good start, is this, are those 4 golden signals that are defined also in the SRE Google book, and it's basically about the request rate, the error rate, the latency, so the duration and the saturation. And I think those are really 4 types that give you already a lot of insights into your system, and also makes it possible to build those SLOs on top of that.
Oh, that was good. Thank you. Marino, I saw you raise your hand. Do you want to go?
Yeah, I actually have to drop in like 2 minutes, but I just wanted to say thank you, Nele, for coming on and sharing a lot of the observability knowledge and perspective. I just wanted to share a different perspective coming from the operations side because observability can be implemented in a number of different ways. And actually, Nele and I developed a talk around how to instrument observability, both at the ops level as well as the app level. And why this becomes important is because there are so many different ways to instrument it, but you have to kind of think of the roots, like why did we even get here? So a long time ago, like, I don't know, 15 years ago, back in my ops days, the recurring themes of observability really came down to logs. We had massive amounts of logs that we were developing and basically were being produced by various systems, and we needed a system to be able to tie all those logs together and create some readable stories, a story that actually helps us figure out what actually went wrong. One of the other challenges we ran into, and Nele brought this up, is around storage, log storage. In fact, a lot of systems didn't have the ability to export logs to a sink. And what would happen is logs would actually crash systems. They would crash servers, they would crash applications. And so you would have to tune them accordingly and say, look, I only want this certain log level, debug, or debugs actually are dangerous because you get everything that comes in versus like an error or a warning. And so when you capture those and then you tie that to things like flow data and policies, you're able to stitch together, what went wrong at a certain time. Now, fast forward to today, we can't do that because of the amount of scale we have, because of all the different microservices that are present. So a simple trace route or a flow, trying to trace a flow is not going to work the same way as using observability tools to instrument across a set of services, right? And so, like when I think about tracing, when I think about trace route, that was a very simplistic form of being able to figure out what's going on in the network. When we think about tracing at layer 7, it's actually much more telling of the stitching of our different services and also telling of where things might be going wrong in our services. So, for example, the call out around there might be something wrong with one service in the path of our entire application. Well, the tools that we have today are able to tell us that. And that's a business problem because that means outages, that means downtime, that means business loss, that means loss of revenue. Now, when you flip that conversation, how do we increase our revenue? Well, we need these observability tools to also tell us our choke points. Where are our choke points happening in the sense of why we cannot scale, why we cannot process more requests, why we cannot process more shopping carts and transactions so that people can buy more, so that we can capture more revenue. That's all a scale issue. And actually, a lot of organizations have hit this in different ways, and they've implemented things like rate limiters and auto scaling and whatnot. But the way we are able to determine that is using telemetry data that is either derived from our application or from the ops side, where we might instrument this in Kubernetes, for example. And I bring this up because there's so many different ways to do observability. Um, but I think it's also wise to know about the fact that applications themselves have the ability to instrument these different points of observability through SDKs, right? And that's why, like when I think about like where do we best instrument observability, there's so many points to do this, and you have all of this data. Once you start to realize like what is the single source of truth, that becomes another set of problems altogether. All right, I gotta go, but thank you so much. I'm sorry I dropped a lot of word vomit there, but I hope this continues the conversation a little bit more. But take care, everyone. Enjoy the rest of this observability space.
Enjoy the holidays, Marino. All right, so Marino definitely left us with a lot to unpack, and there are some ideas there that actually bring several questions to mind. One thing that I'd like to understand more about, honestly, is we talked about just briefly that storing all of the logs can get out of hand. And I'm curious, what is the value of log data to a business? What influences retention policies and things like that? How do you decide what logs to keep and for how long?
That's a good question actually, and I'm not sure if I can fully answer that. I think I guess it depends a little bit on the business context and on the use cases, but in general, the idea to have the log is really the point where you drill down, right? So if you identify something and you are able to look at the log, you really get the information in the log where something maybe went wrong. So the log is a final way of drilling down to the behavior in your system, to a specific call. And I do have to say I can't answer the question about a good strategy here because I I would have to make some up, and I don't like that. So, but I would be interested in knowing if someone here in the space has a good strategy for storing logs and those data. So that would be really interesting to see if someone here, I don't know. I think people can write in the comments, right?
Yeah, definitely. It, if anyone has comments and they want to chime in or otherwise ask questions specifically, definitely jump in and share your strategies too.
I did have one question. So, like Nele, there have been quite a few paradigm shifts between the observability space over the last few years. Initially, we simply scraped some metrics at set intervals. Now we are going even deeper and using eBPF to get insights into applications and infrastructure. So, like, what are your thoughts on this evolving landscape? Do you think there might be room for AI to contribute its part as well?
Oh, yeah, interesting one as well. I think eBPF definitely has changed the space, and I think a thing where I think it becomes quite interesting is because I think Marino touched that what he said. We have all these different layers where we can observe, but often it's also a question of which team is responsible to get the data out. And with eBPF, we have this really we have the benefit of when we instrument, we do it on the kernel level. So no one needs to touch the application code. So if we are on the application layer, we don't have to instrument the application code. And I think that is a promise that eBPF can hold because we get insight there without touching our code, and we can start understanding the application layer. And this contributes basically to the problem that can occur when it comes to the collaboration between, like, hey, who is responsible for the whole observability? Are that the teams in charge of the infrastructure? Are this the teams of the application code themselves? Or is there collaboration, and how does it work? So I think eBPF in that terms makes that easier. Regarding AI, I do think we see that a lot of companies bring AI components into their observability tools. I I don't have see anything like groundbreaking here, where I think that has made it so much easier now that we have AI. I think it can help you a little bit. For example, if you think of query language for Prometheus, if you have something that could like help you write those PromQL queries, that definitely would help in the terms of like AI, I guess. But I think there is still a lot that we can, or that we have to wait at least a little bit what we see in tools happening.
That's interesting. So, like, what are like some of the best practices that one should follow when setting up their observability systems within application?
Well, I think first of all, start with it is a good practice, and I feel if you haven't started, and I think that's really where OpenTelemetry is great in. OpenTelemetry provides those auto agents to instrument your code, so you can use one of those auto agents to get telemetry data out of your application, and that means also you don't have to touch the application code. You can imagine it; it's kind of an agent that runs next to your application and extracts data out of it, and you can make sense already based on that data in open source tools, for example, like Jaeger or like Prometheus, and have some first insights. And I think those are a really good starting point today if you haven't set it up to understand your application's behavior. And then obviously, if you're already there, it's also interesting to investigate into the fine tuning that you can do inside the application context. And that normally happens with manual instrumentation, where also OpenTelemetry provides SDKs. But then, of course, you start touching the code base and you need to change lines of code in order to implement some tracing or some track traces over function calls and so on. That's also something that you can do, but that can get quite interesting, not only in production, but also in the phase before production, when you maybe already have the suspicion that something takes very long, or well, you have a suspicion about certain database calls might be getting a bottleneck. You can instrument that code and those pieces of your application to understand actually if you're, for example, with a load test, if that really is the case.
So, like moving ahead, like I want to explore some real world stories as well, because I think those are best way to understand the benefits of any kind of technologies. So, could you share any examples that you know of where an organization could have increased their application performance exponentially if their observability practices were set up well?
Sure. So I think a really good example are those, or are really like classical ones where your application is up and running, and let's go on something that is maybe the error rate, and the error rate returns maybe like your application on the outside looks up and running because everything is like on a infrastructure level, it's up, but maybe you have that one route that is erroring when you call something, but you haven't really figured out because somehow the test was not testing the specific or whatever the specific input for something. And then in production, you run into the issue. And if you have set up observability and say, hey, I have a error bucket, and that should be always it's 1%. So I have 99% of succeeding calls. At one point, you will feel that this bucket is burning and you get an alert based on that. And then you see basically, so that means you have set up your metrics, you have set up an idea around your API routes, for example, observing them. And then based on that, if you have set up tracing, then you can go to the root cause and you see, okay, or the causality in the system, and you see maybe, oh, this specific call is calling that endpoint, and that endpoint has an input value, and with that input value we query a database, and then maybe in that database we see in the trace there is where the error is happening because we haven't looked into that, or this value really doesn't exist in our database. And then you can see that that this kind of needs to be improved, or that you need to close that gap. I mean, ideally, in an ideal world, it should not have happened because you tested it, but tests are, I mean, sometimes the system passes tests, or you pass by tests. I don't know how to phrase it correctly. And I think that's one case of like, where you can benefit in observing those endpoints and also understanding if your user gets back a 500. And the other thing really, I think it's powerful, it's around the latency and the durations to understand if certain things take a lot of time in your system. And I think those could be sometimes due to different factors. But for example, if you also then understand that you have a duration that is taking longer, and you see the causality, maybe you have a call to an external system, and understanding that the external system is causing it, then there is only something you can do around it, probably, because if it's external to you, can't help. But sometimes it can be also maybe a call to a database that takes longer, and there are different things potentially you can do to debug this and make the system faster overall.
Yeah, like thanks for mentioning all of the things, Nele. Kat, would you like to add on to what Nele mentioned, or any questions?
Yeah, as you were sharing this, I was thinking a little bit about the complexity of logging systems, and kind of rewinding a little bit in my head to what I guess it would have been not quite 5 years ago. I was working in the OpenStack world, right? And on large production clusters running telecom workloads and things like that. And at the time, it was standard practice and common even to SSH to a specific host or a guest VM or something like that, and manually collect logs, pull them down, and things like. And at the time, there wasn't actually any knee-jerk reaction to this being normal and standard way of debugging, right? So I'm curious, what is the story of logging and observability, and how did we get such a complex system? And then I have another kind of question to follow on that, but we'll let you answer that first.
So basically the idea why we look at logs and observability, or why we also look at metrics and trace it, and how it comes together.
Just more contrasting, kind of like what happens if we stick with more traditional methods of collecting logs when things are out, or what are the revolutionary changes in the experience of operating large systems when we adopt more advanced logging systems in place of those manual steps.
Okay, so yeah, I see. Well, I would say probably you will still find those organizations that deal with the old patterns and do the SSHing. So I think that is still something that you would probably find. But then if you combine it into a more modern logging system, you kind of get the like basically the connection between your metrics, traces, and logs easier. And I'm not sure if I answered that correctly, or if that is satisfying. Maybe I'm also have to clarify, I'm not coming so much from the logging background.
No,
So
yeah, no, that's good. What kind of a risk are we talking about, or what are the drawbacks of not adopting logging and tracing ability and observability in an advanced fashion to just an average, medium-sized tech business, right? Like, what are the risks of not modernizing if we haven't done that in large scale yet?
I think the risk would be that you see too late if something is out of order, right? So you get too late, or you get too late aware that something is down, and maybe the prevention could have had happened earlier if you have implemented a good observability strategy. So if you don't do anything, you might get to the point where you think something is not working when your system really is down and in a bad shape. But if you have implemented observability and those types of data, um, or getting out those data in your system, you might have a more fine-graded alerting based on this, and can act more quickly on changes and on external things to your system.
Okay, so now let's shift the conversation a bit to platform engineering. So from my understanding, platform engineering, platforms aim to abstract a lot of operations tasks, be it deployments, testing, or observability. So my question is, how does one make sure that platforms set up the observability practices correctly? How much of abstraction is just right for the platforms?
Yeah, I think platforms definitely help with setting up observability. So there are some examples where platforms already offer the API to do that for you. And I think in general, if you have a platform and it has some out of the box observability you can use, I would recommend starting with that one and see how far you get. And I think there's always a possibility to fine tune, but having a platform and the abstraction layer is a really good start. And you get, for example, I think a lot of those traces from at least the service calls to service calls from most of the platforms that exist nowadays.
Okay, one more question. What tools or technologies do you recommend for effective real-time monitoring?
So I'm on the open source side. I guess you can go with one of the vendor solutions that has everything, or where you buy everything and all. Maybe that works for you. And also that is a discussion. I think that is a different one where you decide to buy a vendor solution, or you kind of use multiple open source things together. I think for metrics to look or to store them, Prometheus is the tool to go for. And for traces, you have multiple options that are like popular nowadays. It's like Jaeger, but also Zipgun, and you have Loki if you stick to Grafana, for example. And then for logs, yeah, maybe I would say Loki, but also the Elastic or the LStack in general. So I think looking to what Grafana has on that side is interesting, and see what you can bring on the monitoring and visualization to Grafana dashboards. But also the LStack from Elastic offers a lot of good support and out of the box things you can implement quite quickly.
That was really insightful, Neil, and I'm sure the audience will also look up into those open source tools. We have one question from the audience as well, and Siddhant says that heading into 2024, what are some of the observability trends that organizations would be adopting more widely? Based on the state of observability, it seemed that some companies still don't have a complete observability solution. What are your thoughts on that?
Yeah, so I think we've touched already on some topics, and I've mentioned open telemetry to be a real like changer when it comes to the instrumentation. And also, what is nice is that it is vendor neutral, and a lot of vendors are actually contributing. And what makes this especially interesting is that all the auto agents that you can use for getting out your telemetry data are really in an advanced state. You can think of like all the engineer excellence of all the vendors are contributing to this auto agent. So using this auto agent, you get out something really good from your application context. So I think that is something we should see more, that companies adopting this, at least as a starting point. Then also eBPF is a topic that definitely will be there, and people will or organizations will experience around with that. And I think a topic that I think will also be there and or is in lines of that is probably also the idea of responsibilities and observability. And that is interesting because it's not only the one layer on the infrastructure, but it also touches the application layer, and then also defining this cross team collaboration and responsibilities of like who is responsible for instrumenting the code base, for example.
So, how do you combine the infrastructure observability data to improve the application performance itself? Can the wider data, that is infrastructure metrics, helps in identifying some performance bottlenecks or security vulnerabilities?
Yeah, I guess it depends a little bit how your infrastructure is set up as well. But for example, if you use a service mesh, you get a little bit of an insight in causality because you see a call graph basically. But the call graph, I mean, it gives you an indication if something is breaking, and you already get an indication where something is breaking in the system based on the edge of your service, right? So that is the first thing where you see something is missing. And then it depends a little bit of if you need more context from your application. And if you need more context, it can be very insightful also to think of that manual approach to instrument the insights of your code base basically to drill down deeper into the application behavior. But I mean, answering your or trying to answer your question, it can be also already a good practice and enough, depending on your architecture and on your services, to understand the edge communication of the services, and based on that, already get an insight where something might break or where you have an error that occurs, that you can start thinking of debugging the system there.
Yeah, I think now I don't have any more questions, and we don't have any more in the audience as well. So we can probably wrap up. But yeah, I'm really glad we did this space today, Neil, and talked about application observability in a deeper level. And I totally love the conversation. So I really want to thank you, Neil, for agreeing to this today. This was really insightful, and I hope all of our audience enjoyed this conversation and got as many insights as I did. Also, a big thanks to my co-host Kat and Marino, who's not here for contributing this to the space with their expertise. So, Milo, before we wrap up, any closing thoughts you would like to share?
Oh, well, first, yeah, well, I mean, I think it was fun talking with you and having that conversation. Would be interesting also to hear what other folks think. I mean, hard if everyone is just a listener, but always feel free to reach out. I'm curious to learn more actually in that space too. So if you like to share your insights, your stories, yeah, feel free to reach out and we can continue the conversation. And yeah, thanks for offering the space, Akansha and Kat. It was a really, really good conversation.
Thank you so much, Niels. And I will now end the space. And thanks for tuning in today. Wishing you all an amazing year ahead and see you in 2024 for more exciting discussions. So, yeah, thanks everyone and have a great day ahead. Bye.